Hello guys, so in today's video we're going to look at the binomial series. Now a binomial expression is one which contains two terms connected by a plus or a minus sign. So for example, these expressions here are binomial expressions. Now we can expand them using the Pascal's triangle for values of n equal to 0 all the way to 8. This triangle here gives us the coefficients of the expansion. So for example, if you're told to expand a plus x raised to the power 4, this is what happens, as you can see here. The values of the first term, which is a, start from the highest power, which is 4, and they go on as they are decreasing by 1. So here we have a raised to power 4. Then in the next term, we have a being raised to power 3, then to power 2, then to power 1, then to power 0. And then the values of x start from 0, that's the values of the second term, and they go on as they are increasing by 1. So x to power 0, x to power 1, x to power 2, x to power 3, and finally x to power 4. Now, the coefficients for this expansion, if we look at the Pascal's triangle here, if we have expressions that are raised to power 4, then the coefficients are 1, 4, 6, 4, 1. So I will have here my coefficients being 1, 4, 6, 4, and 1. So if I simplify this, this is the same as a raised to power 4. X raised to power 0 is 1. Any number raised to the power 0 is 1. And then I have here 4a3x1 plus 6a squared x squared plus 4ax cubed plus a raised to the power 0 is 1. And then I have x raised to power 4. In a similar manner, let's say you're told to expand a plus x raised to the power 3. Now, what happens to the powers of a? They are going to start from 3 as they are decreasing, and the powers of x are going to start from 0 as they are increasing. So I have a raised to power 3, and x will start from 0. Then continuing, a is raised to power 2 now, x is raised to power 1. Then a is now raised to power 1, x is raised to power 2, and finally, a is raised to power 0 and x is raised to power 3. Then putting in the coefficients for when an expression is raised to power 3, coming here to the table, we have 1, 3, 3, and 1. So from the first term, 1, 3, 3, and 1. Now notice that when we are expanding to the power 3, we have 4 terms, 1, 2, 3, 4. And when we were expanding to power 4, we had 5 terms. So basically, whenever we are expanding to the power of a positive integer, we will have a term, 1 term more. If we're expanding to power 4, we will have 5 terms. If we're expanding to power 3, we will have 4 terms, and so on. So simplifying this one, this is a cubed, x raised to the power 0 is 1. So I have 3a squared x plus 3ax squared plus x cubed, since a raised to the power 0 is 1. Now, what if we are told to expand where we have, let's say, a minus x raised to the power 3. Now, the best way to write this is a plus minus x raised to the power 3, such that this is what we are going to take as our second term. So the same procedure still applies. We will start with a raised to power 3 and this raised to the power 0. So I will have a raised to the power 3 and minus x will be raised to the power 0. This will go, the power of this will go on as it is decreasing all the way to 0, and this one will expand all the way to 3. So plus a raised to power 2 minus x is now raised to power 1. plus a raised to power 1 minus x is now raised to power 2. And finally, plus a raised to power 0 minus x is now raised to power 3. Okay, and then we come and write the coefficients for the expansion for when we have the binomial expression being raised to power 3. So checking in our table, it is 1, 3, 3, 1. So I have 1 here, then I have 3 here, then I have 3 here, then I have 1 here. So simplifying this gives me a raised to power 3 because any number raised to the power 0 is 1. And then this, because of this minus here, so this gives me minus 3a squared x. And then this here minus x squared is the same as positive x squared. So this gives me plus 3a x squared minus x cubed is the same as minus x cubed. So this gives me minus x cubed, which is my answer. Now, guys, since this Pascal's triangle limits us to expand for values of n from 0 all the way to 8, we have the binomial theorem. The binomial theorem, which is given by this formula here. And this binomial theorem will help us expand for all values of n. So whether n is a very big positive integer, whether it's a fraction, or whether it's a negative number. Now, one thing you need to note is that for n being equal to a fraction or negative number, the expansion is infinite. It does not come to an end. So most of the time in the question, they will tell you where to stop. Now, let's take up an example. So let's say, let's just take up an example from what we did from the previous one, a plus x raised to power 4. So when you're told to expand such, this is what is going to happen. Your a is a here, your x is a here, and your n in this case is 4. So because it is raised to power 4, we are going to have how many terms? We're going to have 5 terms as we saw previously. So 1, 2, 3, 4, 5. We're going to go all the way to that term. Now what happens? The value of a is first of all raised to power n. That is raised to power 4. In our case, n is 4. Plus we have n there. So 4, a raised to power n minus 1. So that is raised to power 3. Then we have x plus n. So we have n is 4, then n minus 1, so that is 3, 4 minus 1, which is 3, and then a is raised to power n minus 2, so a is raised to power 4 minus 2, which is 2, and then x squared, all this divided by 2 factorial, plus n, which is 4, n minus 1, which is 3, n minus 2, which is 4 minus 2, so that gives 2, and then a n minus 3, so that is 4 minus 3, which gives 1. Then x is raised to the power 3, all this divided by 3 factorial, plus we have n, which is 4, then 3, then 4 minus 2, which is 2, then 4 minus 3, which is 1, then a is raised to the power 4 minus 4, which is 0, then x is raised to the power 4, and all this is divided by 4 factorial. So let's check 1, 2, 3, 4, 5. We have 5 terms and we are done. Now notice we started with a raised to power 4 and we finished with a raised to power 0. X was initially raised to power 0, though not written here. X raised to power 0, and we go all the way to x raised to power 4. So this is our answer. Now, to simplify this, we simplify the factorial notation. So 2 factorial basically means 2 times 1. 3 factorial means 3 times 2 times 1. And 4 factorial means 4 times 3 times 2 times 1, and so on. We can as well evaluate the factorial notation from the calculator. So you press, let's say you're looking for 2 factorial, you press on 2, then press on shift, then you press on the factorial notation. You press on this button here, then you will get your answer. So simplifying this over here, we have, so a raised to power 4 plus 4a raised to power 3x plus 4 times 3. Now 2 factorial is the same as 2 times 1, which is 2. So 2 will cancel with this 2, and we have this as 6a squared x squared. Now 3 factorial is the same as 3 times 2 times 1, which is 6. So we will have this canceling with this. So we remain with 4ax raised to power 3. 4 factorial is the same as 4 times 3 times 2 times 1. So the whole of this 4 factorial will cancel with the whole of that. A raised to power 0 is 1. So we remain here with x raised to power 4. As you can see, so this is the answer. So basically, that's how we go about expanding using the binomial theorem. Now, let's say we have this example here. You're told to expand 1 plus, 1 plus x raised to the power 3. Now, come and relate it to the binomial theorem formula that we have here. So let your a be equal to 1, and x will still remain to be x. So x is equal to x, and your n is equal to 3. So in the binomial theorem formula here, where we have a, we will replace with 1. Where we have x, we'll put x. And where we have n, we will put 3. Now, this right here is raised to the power 3. So we are going to have 4 terms. So we will go all the way to 1, 2, 3, 4. We will go all the way to here. So let's start expanding. So the first term is a raised to power n. That is, in our case here, 1 raised to the power 3, plus the second term is n. So our n is 3. A raised to the power n minus 1. Our a is 1. So 1 is raised to the power 3 minus 1. So that is 2. Then we have x plus n and n minus 1. So that is 3. N minus 1 is 3 minus 1, which is 2. Then we have a raised to power n minus 2. So our a in this instance is 1. 1 is raised to the power 3 minus 2, which is 1. Then we have x squared besides it. All this is divided by 2 factorial. Plus, we are here now, n, which is 3, n minus 1, which is 2, n minus 2, which is 3 minus 2, and that gives 1. Then a raised to the power n minus 3, so 1 raised to the power 3 minus 3, so that will give 1 raised to the power 0. Then we have x cubed. All this is divided by 3 factorial. So simplifying this, 1 raised to the power 3, any number, 1 raised to the power of anything is 1. So that will give us 1 plus, we have 3 times 1 times x, that will give us 3x plus, now 2 factorial is the same as 2 times 1, which is the same as 2. So this will cancel with this, and then we remain with 3x squared, and then plus 3 factorial is the same as 3 times 2 times 1. So the whole of this 3 factorial will cancel with the whole of that. 1 raised to the power 0 is 1, and then we have here x cubed. So this is the answer to our expansion. Now let's take up another expression. Now, before we do that, I want us to notice that there's some recursion formula and this formula. Now, as you can see, the values of a starts from a raised to power n, and they go on as they are decreasing by 1, just the same way in the Pascal's triangle. So we start with a raised to power n, then a is raised to power n minus 1, then a is raised to power n minus 2, then n minus 3, and so on. So just in case we were to come up with the next term in this expression here, then we would obviously know the value of our a will be a raised to power n minus 5. So we would have our a in the second term being raised to power n minus 5. But just a minute, let's look at the values of x. We start with x raised to power 0, so it's not written because x raised to power 0 is the same as 1, then raised to power 1, then to power 2, then to power 3, to power 4. So obviously, if we were to have another term, then it would be x raised to the power 5. And then for the coefficients, as you see, we start here with 1, then n minus 1, all this divided by 2 factorial. Now here the factorials are not there, but they are actually present because this is 0 factorial and this is 1 factorial. It's just that 0 factorial is the same as 1. If you evaluate in the calculator, you will see. And 1 factorial is also equal to 1. So writing them, not writing them, more or less the same thing. Huh? So if we were to come up with the next term, then obviously, as you can see from the formula, we would have n, then n minus 1, then n minus 2, then n minus 3, and then n minus 4. N minus 4. Then the values for a will be a n minus 5. Then the value for x will be x raised to power 5, and all this is divided by 5 factorial. Okay, now let's say you're told to expand 1 minus x raised to the power 4. Now, it's important that you write this such that it's corresponding to the binomial theorem so that you're able to choose your values correctly. So I'm going to write it as 1 plus, then I let this be minus x, all this divided by 4. Plus minus is just the same as minus, but I want my expression to look like this so that this is corresponding to this term here. This one is corresponding to this and this to this. So in this case here, I will take my a to be equal to 1, my x to be equal to minus x, and my n to be equal to 4. So what will happen is that where there's a in the binomial theorem, I will put 1. Where there's x, I will put minus x, and where there's n, I will put 4. Now this is raised to power 4. So how many terms are we going to have? We are going to have 5 terms. So let's go on and expand. So the first term is a raised to power n. That is 1 raised to the power 4 plus n. So we have 4. A raised to power 4 minus 1. So that is 1 raised to the power 4 minus 1, which is now raised to power 3. Then we have x. So in our case here, our x is minus x. Plus, we are here now, n. So 4. Then n minus 1. So 4 minus 1, that gives 3. And then our a is raised to power n minus 2. So 1 raised to power 4 minus 2. So that is 1 raised to power 2. And then x squared. And our x at this instance is minus x. And then we square it. And all this is divided by 2 factorial. Now plus, we are on to our last term. Now notice that we have 4, 3. So here we are going to have 4, 3, and then we have 2. And then we have 1 raised to power 2. So you can see the values of 1, their powers are decreasing. So we will have here 1 raised to power 1, and minus x is now raised to the power 3. And all this is divided by 3 factorial. And finally, just following the same method, we will have 4, then we will have 3, then we will have 2, then we will have 1. And then 1 will now be raised to the power 0 as the powers of 1 are decreasing, and minus x will now be raised to the power 4. And all this is divided by 4 factorial. So simplifying this will give 1 plus, actually it's going to be minus because of this here. So we'll have this as 1 minus 4x plus, so you see this is 2 factorial, which is 2 times 1, which is the same as 2. So 2 will cancel with this. We have 2. 2 times 3 will give us 6, minus x squared will be positive x squared. So this will give me 6x squared. Now 3 factorial is the same as 3 times 2 times 1. So this 3 factorial can cancel with this 3 times 2 times 1. Minus x cubed will give us minus x cubed. So I will have here minus 4x cubed. 4 factorial is the same as 4 times 3 times 2 times 1. So this 4 factorial will cancel with the whole of that. 1 raised to power 0 is 1. Minus x raised to the power of 4 will be positive x raised to the power 4. And this right here is our answer. Now, let's say you're told to expand and you're given either n as a fraction or n as a negative number. So let's just take this so that we don't have to write it again. Okay, so okay, fine. Let's just write it all over again because it is taking a lot of time. So we have a plus x raised to the power n. So this is the binomial theorem formula. A is raised to power n plus n, a raised to power n minus 1, then x plus n minus 1, a raised to the power n minus 2, x squared, all this divided by 2 factorial, plus n minus 1, n minus 2. Now a is now raised to the power n minus 3, x is now cubed, all the way divided by 3 factorial, plus n minus 1, n minus 2, n minus 3. A is now raised to the power n minus 4, x raised to power 4, all this divided by 4 factorial. Okay, so let's say you're told to expand 1 plus x raised to the power of negative 3 up to the term in x cubed. So basically, since our n here is a negative number, as I said before, the expansion is going to be infinite, so it does not have an end. So as we can see clearly, the question says that we expand all the way to x cubed, so we will get all the way to this term. So let's go. We're going to choose our a to be equal to 1, corresponding to the formula. Then our x is just equal to x, and our n in this case is minus 3. So in the formula where there's a, we will replace with 1. Where there's x, we will put x, and where there's n, we will put minus 3, and we're expanding all the way to here. So what's our expansion going to look like? A raised to power n, that is 1 raised to the power minus 3, 1 raised to the power minus 3, plus n, which is now a minus 3, a raised to the power n minus 1, so our a is 1, 1 raised to the power minus 3 minus 1 will give us minus 4. Then we have x, which is just x, plus n. Our n in this case is minus 3. Then we have n minus 1, minus 3 minus 1 is minus 4. a raised to power n minus 2, that is 1 raised to the power minus 3 minus 2, so that is 1 raised to the power minus 5. Then we have x squared. Our x is just x, so we'll just have x squared. All this is divided by 2 factorial. Then finally, plus n, our n is minus 3. Then we have n minus 1, so that will give minus 4, n minus 2, that will give minus 5. Then a is raised to the power n minus 3, so 1 raised to the power minus 3, that will be minus 6. And then finally, x cubed, all this divided by 3 factorial. Then we simplify our answer. So now this is the same as 1 raised to the power of anything is just 1, minus 3 multiplied by 1 times x, because 1 raised to the power of anything is 1. So this will give minus 3x. Now remember, 2 factorial is the same as 2. Is the same as 2. So 2 divided by 2 here, I will remain with minus 2. Minus 2 multiplied with minus 3 will give me positive 6, 1 here, and then we have x squared. 3 factorial is the same as 3 times 2 times 1, which is the same as 6. So 3 goes here, then I remain with minus 1. 3 goes here, I remain with 2. 2 goes here, I remain with 1, and 2 goes here, I remain with minus 2. So minus 1 times minus 2, that is 2. 2 times minus 5, that is minus 10. And 1 is raised to the power of minus 6, so that just gives 1. Then we have x cubed. So this right here is our answer. Now, let's take up another example. Let's say you're told 1 plus x raised to the power a half up to the term in x squared. As I've said before, when it is raised to the power of a negative number or a fraction, the expression is infinite. It does not have an end. So as you can see, the question has said, we expand all the way to x squared. So all the way to x squared, that is all the way here, we're going to have 3 terms. Now, in here, let's relate it to our formula. Our a will be what? Our a will be equal to 1. Our x will be corresponding to x in this question, and our n in this case is a half. Now let's replace the values in the formula. So a is raised to power n. We have 1 raised to power a half plus n, which is a half. Then a raised to power n minus 1. So that is 1 raised to power a half minus 1. So that will give minus a half. And then a raised to power n minus 1. So we've already done that. So that is 1 raised to power a half minus 1, which gives this. And then we have x plus here. Finally, n, which is a half. Then a half minus 1, which is minus a half. And then a raised to the power n minus 2. So that is 1 raised to the power a half minus 2. So a half minus 2 will give us minus 3 over 2. And then we have x squared. All this is divided by 2 factorial. So that's our last term. Then we now simplify. So simplifying this, 1 raised to the power of anything, this is 1, a half, 1x. So this will give me x over 2. And then I have 2. So I have a half multiplied by minus a half multiplied by 1. So a half, if you multiply by minus a half, will give you minus a quarter. Then multiply by 1, you'll still get minus a quarter. And then you have times x squared. And then it is divided by 2 factorial. Now remember, 2 factorial is the same as 2. So if I am taking the whole of this and I'm dividing by 2, it is the same as me multiplying by the reciprocal, which is a half. So that will give me 1 over 8. So I will have here plus 1 over 8 x squared. And that right there will be my answer. Now, in some questions, you will be given the binomial expression written in the denominator. So let's say you have something like this. let's say you have, so should we write the binomial theorem again? So I think we can write it again. We have a plus x raised to the power n. This is a n plus n minus 1, x plus n minus 1, a n minus 2x squared, all this divided by 2 factorial plus n minus 1, n minus 2, a raised to power n minus 3, x cubed, all this divided by 3 factorial, and it goes on and on. So let's say you're given an expression like this. You're given something like 1 over p plus q raised to the power of minus 3. And you're told to expand. Now, in order for this to correspond to our binomial theorem, we will bring it up onto the numerator. Now, p plus q raised to power minus a third. If you bring this up, this will be p plus q raised to the power of positive 3. Then we can go on and now carry out our expansion. So at this instant here, our a will be corresponding to p, our x in the formula will be corresponding to q, and our n will be corresponding to 3. Okay, let's go. So where there's a, I will replace with p. So I will have p raised to power n, which is p raised to power 3, plus n, which is 3, a raised to power n minus 1, which is p raised to power 3 minus 1, so that is p raised to power 2. Then x, our x in this question is q, plus n, which is 3 minus 1, which is 2, and then a raised to power n minus 2, so p raised to power 3 minus 2, so that will be p raised to the power 1, and x squared, our x is q, so q squared, and all this is divided by 2 factorial, plus n, so our n is 3, then 3 minus 1, which is 2, and then 3 minus 2, which is 1, and then a raised to power n minus 3, our a is p, so p raised to power 3 minus 3, that is p raised to power 0. Then x cubed, our x in this case is q, so q raised to power 3, all this divided by 3 factorial. Simplifying this, we have p cubed plus 3p squared q plus 2 factorial is the same as 2, so this will cancel with this, and then we remain with 3p q squared plus 3 factorial is the same as 3 times 2 times 1. So this will cancel with this. P raised to power 0 is the same as just 1. Any number raised to power 0 is 1. Then we have Q3. So this right here is our answer. Okay, so we stop there. I will continue with part 2 of this next time.